So far, we've seen both horizontal asymptotes and slant asymptotes, but there is a third possibility for the end behavior of rational functions. We're going to put this as number 4, though, because numbers 1 and 2 both corresponded to horizontal asymptotes, and 3 corresponded to a slant asymptote. So now the fourth possibility, if the degree of P is at least the degree of Q plus 2. So if the numerator has a degree that's at least 2 more than the denominator, then the end behavior is the same as the quotient of the leading terms. And I'm going to give you an example so that you can see exactly what I mean by this. Let's consider r of x equals x cubed minus 2x squared plus 3 over x minus 2. Now, I've said that the end behavior is the same as the quotient of the leading terms. So if we look at the leading terms here, we've got x cubed over x. So x cubed over x, we know that this is equal to x squared. And so the end behavior matches y equals x squared. We know that this is a parabola opening upward, so the graph is going to be going up as we move to the left towards negative infinity, and also as we move to the right towards positive infinity. So we can say that y approaches infinity as x approaches negative infinity, and also y approaches infinity as x approaches positive infinity. Now, I do want to explain why this is the case, and we can do so by doing the division out. So let's use synthetic division here. The coefficients in the numerator are 1, -2, 0, and 3, and the value of c is 2 here. We bring down the 1, we multiply, we add, we multiply, we add, we multiply, and we add. And so what we end up with here, when we take the quotient, is x squared plus 3 over x minus 2. So what we end up with is a polynomial out front. In this case, it's a monomial, but it could have more terms. And then this remainder term. Now the remainder, when x gets very large in either direction, this is going to get smaller and smaller and be inconsequential. So what matters actually is the polynomial out front. And we know that the end behavior of a polynomial comes exclusively from the leading term. And the leading term, x squared, is what we get when we look at the quotients of the leading term of our rational function. So because this function can be expressed as x squared plus this fractional term, and the fractional term gets smaller and smaller as we move towards infinity and negative infinity, the behavior is modeled off of x squared, which tells us we're moving up in each direction. And here we have a graph of the function. We can see a vertical asymptote at x equals 2, which we expect because when x equals 2, the denominator is 0 and the function is undefined. And then outside of what's going on in the middle, we can see that the end behavior has the graph going up towards positive infinity when we move in both directions, as x goes to the left towards negative infinity, and as x goes to the right towards positive infinity. So this is the last scenario we can have as far as end behavior goes. So either we have a horizontal asymptote, we have a slant asymptote, or we have end behavior that looks like a polynomial. And always the way to figure this out is by looking at the degrees of the polynomials in the numerator and denominator, and then using this sorting method that we've learned in this lesson.